SANS 1200G by iQS. This presentation will cover the SANS 1200G document, which is Civil Construction Concrete. A civil construction project was chosen as a case study, and the bill for the concrete work will be analyzed in terms of method of measurement used and what is stated as per the SANS 1200G document. The SANS 1200G standardized document will be discussed in terms of its structure and contents. If the SANS-G document differs from the bill that is provided by the project at hand, changes will be presented and discussed. Furthermore, the scope of works for this project will be discussed in this presentation. Concrete, formwork and reinforcement information will be discussed and evaluated. First, we will take a look at NAMIC Civils, who are the contractors in charge of delivering this project. NAMIC Civil Construction is the company that we approached for the compilation of this presentation. NAMIC is a civil and mechanical engineering contractor that delivers their services to the Western and Northern Cape regions. NAMIC are also responsible for various civil concrete projects, but the site closest to UCT is that of the Steel Water Reservoir. The reservoir is being constructed for the City of Cape Town, but two other contractors are present on the site as well, due to the contract agreement set out by the City of Cape Town. This part of the presentation will cover the project brief. The project is isolated and located in Philippi in Cape Town and is a construction of a reinforced concrete ring beam which is to support a circular steel water reservoir. The reservoir is being built by the City of Cape Town to alleviate strain on the water catchment dams that feed into the main water supply pipeline. The site area is just shy of 6,400 square meters and the reservoir is built to contain 3 megalitres of water. The scope of works for the project includes all SANS C and D items that have been discussed in the previous assignment presentation. Site clearance and light earthworks preceded the construction of the ring beam. Thereafter, the placing of formwork to an accuracy of level 3. Placing of Y12 steel reinforcement bars and R10 stirrups creates the reinforcement cage needed before the concrete is placed. The concrete is cast in sections due to the length of the ring beam. The middle of the reservoir is compacted to 95% mod AASHTO density, and the placement peg is put in place to identify the center of the reservoir. Further in this presentation would be the project requirements. 35 MPa 20 mm stone concrete was used for the construction of the ring beam. The tolerances are listed in the drawings provided and are seen to be very low due to the level of accuracy needed for the water reservoir. The radius to the outside of the beam is 11 meters.
This is an overview of SANS-G. The first item, which is clause 8.1.1, is formwork. The general principles of measurement of SANS-G are discussed here. Formwork is measured in meters squared. Formwork is measured as separate items for horizontal, sloping, battered, and vertical types, and for the class of finish as well. The class of finish for the formwork could be rough, smooth, or special. Horizontal formwork is exceeding 85 degrees and not exceeding 95 degrees. Sloping formwork is exceeding 10 degrees and not exceeding 85 degrees. Battered is less than 10 degrees and vertical is 0 degrees. The next clause is reinforcement, which is 8.1.2. Reinforcement is measured in tons. Each steel section or mesh is measured separately. However, no allowance is made for cutting, waste, laps, spacer divides, or binding wire. The rates include supply, cutting, bending, placing in position, and fixing in position, including space dividers and for the binding wire. 8.1.3, which is concrete. Other concrete items are measured as separate items in terms of grade of concrete, cement, aggregate, each unit of works, and each element. It is measured in meter cube. The rates include design of mix, supply of concrete, placing, compacting, forming of construction joints. 8.3 and 8.4, these are the scheduled reinforcement items and the concrete items. Clause 8.5, which is joints. Joints are measured in meters. Separate items are measured for contraction and expansion joints of different types and sizes. The rates cover the cost of all materials and labor for construction of each joint, including cost of formwork, testing, and making grade. The next clause, 8.6, which is manufacture and erect precast elements. This is measured in numbers or in meter cube. Separate items are measured for different qualities of concrete, types and sizes of units. Grouting, clause 8.7. This is measured in meter cube for grouting and the bases and in tons or in numbers for HD bolts. 8.8. HD bolts and miscellaneous metalwork. This is measured in tons, however, it needs to state whether supplied by contractor or others, and the rate covers costs of supplying and delivering or taking delivery, fixing or casting in concrete, and all cleaning, preparation, and finishing.
Due to the scale of the project in comparison to all the steelwork that had to be done to install the tanks, the concrete work was relatively small. Therefore, it may have been why the contractor chose to include one provisional sum inclusive of all the concrete works that had to go with.
As there was only one item included in the BOQ for concrete, we decided to list and discuss the correct way in which to measure according to SANS G. In this section, I shall discuss the relevant clauses to this project and mention which clauses should have been included in the BOQ. So starting with formwork, the first clause which should have been included in the bill is clause 8.1.1.1. This clause states that for the measurement of formwork, the net area of the face of the concrete is to be measured in square meters and there is to be no deductions for openings of diameters less than 0.7 meters or areas up to 0.5 square meters. It is also mentioned in 8.1.1.3 that separate items should be made for each class of finish, for example rough or smooth formwork. Clause 8.1.1.3b states that separation is necessary according to the angle of inclination from the vertical angle. This was earlier spoken about by Sajjad. The four angles of inclination are horizontal, sloping, battered, and vertical. Then clause 8.1.1.3c further states that a clause should be added if formwork is to be curved. Therefore, an additional item has been added describing the shape of the formwork as circular. The final description describes the element to which the formwork is formed against. In our case, the formwork is placed for the casting of the ring beams. With every item, there should be a cost component to it, i.e. a rate. According to clause 8.1.1.6, this rate should include all supports to the formwork, including labor and plant to erect and strike it. In summary, the items which should have been included in the bill for concrete is that formwork is to be smooth, to be cast at a vertical angle, the formwork is to be circular, and the formwork is to be used for the casting of the ring beams. Now, reinforcement. The next element which should be included in the bill is reinforcement. The first classification for which the reinforcement is separated into is the strength of the steel reinforcement bars. These can be classified as either low, medium, or high tensile reinforcement bars. For the measurement of the reinforcement, clause 8.1.2.1 states that the reinforcement should be measured as a total weight of all rebar used in the concrete. The method in which to measure this is by multiplying the mass of the bar by the length of such bar. The unit in which the measurement is classified is tons. There should also be no allowance for cutting, waste, laps, space dividers, etc. An additional assumption should be made about the diameter of the rebar in clause 8.1.2.2a, which states the diameter of rebar is used to calculate the weight of reinforcement used in the structure in order to price it in tons. The diameter of steel reinforcement is assumed to be 25 mils diameter just to obtain an estimate for the purpose of obtaining a contract price. The diameter of rebar used in this rebar was stated as 10 mils and 12 mil diameter. The unit rate of reinforcement is discussed in clause 8.1.2.3 and states that the rate of reinforcement bars covers the cost of supply, cutting, bending, placing in position, fixing and support, the spacers and binding wire, and the test of the rebar. For our measurement of the rebar, we separated the mild steel bars from the high tensile steel bars. Below each item is the diameter of the bar used, and the quantity is then calculated based on this diameter, length, and number of steel bars used. The final element, which should have been included in the BOQ, is of course concrete. According to clause 8.1.3.2, separate items are to be measured according to this type of concrete: grade of concrete, type of cement, aggregate, and other elements of work which have cost implications, like the position, surface finish, slope, and if the concrete is to be cast underwater, etc., etc. Clause 8.1.3.2d furthermore states that separate items should be used according to the type of finish given to the concrete, such as wood floated or steel floated, and granulithic or mortar screeds. Clause 8.1.3.3a describes the measurement of rates used for concrete. It states that the rate shall cover the cost of the design and mix of concrete, the mixing, supplying, placing, and compacting of concrete. The concrete element. The concrete used is first stated along with the mix, which is essentially the strength of the concrete. As mentioned earlier, separate items are to be made for the finishes, so an item is included below the concrete item, describing the finish to the beam, which in this case is wood float.
To conclude, the BOQ that iQS was provided with was not according to SANS G, rather it was measured as a lump sum item, all in one, in an Excel document. That is why iQS took the initiative of preparing a SANS G BOQ and to compare it to the Excel document. There was not much concrete civil works involved in the project, but the construction of the reservoir was very interesting. The concrete specs were very specific to fit the reservoir perfectly in terms of loading, dimensions, and movements.
Thank you for listening to our video.
Thanks.